Astronomers offer a theory about a mysterious location of massive stars. According to Georgia State University findings on phys.org, astronomers from Georgia State University found an explanation for the strange occurrences of massive stars located far from their birthplace in the disk of our Milky Way galaxy. So what happened to them? Did they get pulled away for some reason? Stars more massive than the Sun have very hot cores that drive nuclear energy generation at very high rates. They are among the brightest objects in our galaxy, but because they burn through their hydrogen fuel so quickly, their lifetimes are relatively short, perhaps 10 million years compared to 10 billion years for the Sun. Their short lifetime means that there is little time for them to stray too far from their birthplace. Most massive stars are found in the flat disk part of our galaxy, where gas clouds are dense enough to promote star birth, and where astronomers find young clusters of massive stars. So when a massive star is found far from the galaxy's disk, how did it get there? Astronomers are finding massive stars far away from their place of origin, so far in fact that it takes longer than the star's lifetime to get there. This is what Georgia State astronomer Douglas G. says. How this could happen is a topic of active debate among scientists. This is the problem presented in the massive star known as HD 93521 that lies about 3,600 light years above the galaxy's disk. A new study by Geese and other astronomers from Georgia State reveals a profound discrepancy. The flight time to reach this location far exceeds the predicted age of this massive star. The astronomers used a new distance estimate from the European Space Agency's Gaia spacecraft, together with an investigation of the star spectrum, to determine the star's mass and age as well as its motion through space. They find that HD 93521 has a mass about 17 times larger than the Sun's, and this leads to a predicted age of about 5 million years. On the other hand, the motion of the star indicates that its journey from the disk had taken much longer, about 39 million years. The Georgia State astronomers explained this strange difference between the star's lifetime and travel time by suggesting that HD 93521 left the disk as two lower mass and longer lived stars rather than the single massive star we see today, and their findings have been published in Astronomical Journal. The cue to the mystery is that HD 93521 is one of the fastest rotating stars in the galaxy. Stars can spin up through stellar mergers, where two close orbiting stars can grow over time, colliding to form one star. Guy says HD 93521 probably began life as a close pair of medium mass stars that were fated to engulf each other and create a single fast-spinning star we see today. Such intermediate mass stars live long enough to match the long flight time of HD 93521. HD 93521 is not the only case of massive star found so far away from its birthplace. Georgia State graduate student Peter Wysocki is investigating an example of a distant massive binary pair that's probably representative of the stage just before the merger. This star is known as IT Libre, and it has an orientation that creates mutual eclipses that the two stars pass in front of each other. An investigation of the variations in the light output and motions detected in the spectra leads to estimates of the stellar masses. Wysocki finds a similar conundrum from the mass results. The predicted age is much less than IT Libre's travel time from the disk, but the study also reveals that the lower mass star in the pair has already begun to transfer much of its mass to the higher mass star, initiating the process that may eventually lead to a merger. This means that the higher mass star is actually older than it appears, having begun life as a lower mass star. So these distant massive stars provide striking evidence that close pairs of stars can merge to make even larger stars, Guy said, and there are cues about how rapidly rotating massive stars are able to create black holes with large spins. This is by Georgia State University on phys.org. Please leave your comments and thank you for your support. Finally, support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box